Hello, everyone. I hope you can all hear me. I'm going to start now. We might have a few people coming in late, but I'm just doing a brief introduction. My name is Audrey Wilson, and I am the Community Engagement Officer at the Scottish Council and Archives. And I welcome you to our fourth webinar in the series, Developing Your Digital Skills, an Introduction to 3D Digitisation. So today we hear from Frederick Alexander, Digital Archivist on the Historic Environment of Scotland's Rock Art Project. And this presentation will introduce using 3D modelling to digitise your collections. We have already covered the digitisation of flat documents, and last week Maya Darrell-Hewen presented on the digitisation of film and sound collections. This webinar is being recorded and will be made available on the Scottish Council and Archives and the CAJ websites, and I will post a link on Twitter later. We did have some technical issues with our webinar on 2D digitisation. We're sorting that out, and we will post a link to the recording as soon as possible. So just a couple of notes on housekeeping. As an attendee, you can submit questions in Q&A or use the chat room. I very much encourage you to do that. I'll keep an eye on your questions, and I'll put them to Freddie at the end of his presentation. The other thing is you might want to use the closed caption option. This is where the speech is reproduced in words at the bottom of your screen. You will see a box that has 2 C's in it. Click on it and scroll down until you can turn on closed captions. That's if you choose to do that. I will warn you, it's not always accurate, especially if you're using technical language, but it does help for some people. So without very much more delay, I think we've got everyone who's coming that has now joined us. I will pass over to Freddie. Thanks very much, Freddie.
Thank you so much. I'm really excited to be presenting with you all today. So with that being said, let's get started. Welcome everyone to this presentation on digitizing 3D objects. My name is Frederick Alexander. I also go by Freddie. So I'm excited to be meeting all of you, albeit virtually. In this presentation, we're going to go over what 3D modeling is. This might be something that is new to some of you. Some of you may have encountered this before, but we're going to give a little bit of an introduction to that. After that, we're going to focus specifically on a type of 3D modeling called 3D photogrammetry. This is the type of 3D modeling that I work with, and also the type of modeling that I believe might be of greatest interest to you and your heritage collections. There are other types of modeling which I will touch on over the course of this presentation. After that, I'm going to look at how we have used 3D photogrammetry in Scotland's Rock Art project. This will give you a little bit of context as to how 3D modeling provides new insights into objects. And finally, we're going to consider how photogrammetry could be used in your heritage collections, potentially looking at that a little bit further in the Q&A session. But firstly, I want to give a quick introduction to what we do at Historic Environment Scotland. Some of you may have encountered us, some of you may have not. Historic Environment Scotland is the lead public body set up to investigate, care for, and promote Scotland's historic environment. What is the historic environment? It is the physical evidence of past human activity. It connects people with place and with tradition, stories, and memories. This could be a castle, a garden, a battlefield, or a photograph. Historic Environment Scotland's archive is part of this. In our archive, we hold photographs, records, building plans, architectural drawings, and models. We've also collected digital archive material since 1990 and recently passed a milestone of 1 million digital records in our archive. So it's a little bit of a pretty substantial collection. Here are some of the organizations that we either support, operate, or deliver material through. You may have engaged with some of these in the past. I would encourage you to look into any of the ones you don't know about. And if that all feels a little bit abstract, here are some numbers that detail what we do. As you can see, our work is very wide-ranging across a whole host of elements that touch upon Scotland's heritage. As a digital archivist with Historic Environment Scotland, I am responsible for preserving the digital records of Scotland's heritage. This may be a digitized photo album of the Hunterston B nuclear power station that I recently worked to made publicly available online through our Canmore website, or raw geophysical survey data that reveals hidden Roman forts in the Scottish countryside. Currently, I'm working with Scotland's Rock Art Project, which is a collaborative project between the Arts and Humanities Research Council and Historic Environment Scotland, which is looking to preserve and promote prehistoric rock art throughout Scotland. So that's a brief introduction as to what I do and what Historic Environment Scotland does. But now we'll talk about what 3D modeling is. What I want to get across at the start of this presentation is that 3D modeling is actually an umbrella term. It refers to a variety of techniques that are used to make digital representations of 3D objects. You may feel like you've not ever interacted with 3D models, but I promise you, you have. If you've ever played a video game or watched a blockbuster movie or looked up the weather or even driven in a car, you will have engaged with a product or a object that has been generated through 3D modeling. There are lots of different 3D modeling techniques, but I'll touch on some of them just here. For instance, in the top right, you can see there looks like the image of a mug. This is generated using computer-aided drawing techniques. These use mathematical equations to generate a model that can then be adjusted according to the equations. This is very good at generating a 3D model that is exactly the same throughout its generation. What is this used for? This is very useful for if you're building something, say an airplane or a car, where you need every part of the vehicle to be the exact same, otherwise something bad could happen. Below the mug, you can see an example of a LiDAR model. This is conducted using laser scanning. This is one of ours, and it reveals a fort that is currently a little bit difficult to see if you're just taking a photograph of it. This is a very good technique for generating a 3D model of a large object. You can either fly a drone over the object, or you can do it with a handheld device. And these scans use lasers to generate point clouds, which can then be viewed. The final one that you can see in the center there is another one of ours. It's a polygon mesh. This touches a little bit on what 3D photogrammetry is, but it can be used by other methods of 3D modeling. And what this does is it generates points and vertices for an object, which can then be layered with textures and colors to recreate that model in a virtual space. So let's take a look at that. If that was potentially a little bit complicated, I hope this slide clarifies it. This is actually a slide that I've borrowed from an English heritage presentation, which I thought helped to illustrate this a little bit better. So as you can see, 3D modeling, its uses and its usefulness, the different techniques apply to really what you want from it. If you are wanting to generate a very complex image of something that is quite small, you may be better used to using something like photogrammetry. Whereas if you're wanting to generate an object that is very large, either a building size or an entire region, you may want to use more advanced technologies like a laser scanning technology. This is all kind of starting to think through the process of what 3D modeling technique do I want to apply to my collections if I wanted to go through that. So for instance, here is one of ours. This you may recognize as the Sydney Opera House, which has been generated using a combination of techniques, primarily laser scanning, but with some large-scale photogrammetry as well. This was generated as part of the Scottish 10 project, a project to capture Scotland's 5 World Heritage sites. And it's not just the Sydney Opera House that we've captured. We've actually captured most of Sydney Harbour as part of this project, and you can engage with that as a 3D model. Here's another example, a bit smaller scale. This was done by the Natural History Museum. And this is part of the Darwin Fossil Collection, which is currently you can view on a website called Sketchfab. I'll explain what that is a little bit later on into this presentation. So that's an overview of kind of 3D modeling as a broad subject. What I want to do just now is drill down into a specific technique for 3D modeling called photogrammetry. What is 3D photogrammetry? Photogrammetry, it's both an art and a science. What it does is it extracts information from 2D images and then constructs a 3D model from it. Let's take the car as an example. If I took one picture of this car, I would only be able to see it from one angle. However, if I took another picture of the car from a different angle, I would be able to see more of the car. However, I would still only have 2 photographs, each being limited in what they could show me. However, with 3D photogrammetry, what I could do is take, say, 100 pictures of the car, each at a different angle, potentially orbiting around it. What I could then do is take each of those photographs and find common points within them. Say, for instance, the left-hand tire, for instance, as a point. I could tell how far, using all of these photographs, each other point of the car was from the left-hand tire, say, the windshield or the exhaust pipe. What I could do then is create a point cloud from all of these points and stitch them together using polygons, which is something that we saw a little bit earlier. Finally, I would layer that polygon mesh with the textures and colors of the car, a smooth metallic exterior with red and black in this example right here. Now that's breaking down each stage of what 3D photogrammetry is, but what is really helpful is that there are computer softwares that do this automatically for us. For example, we use Archivist Metashape in Scotland's rock art project, for which all we do is provide the photographs. The software then conducts each stage in turn for us that we can then monitor and review at each stage. That's a little bit of an introduction for what 3D photogrammetry is. Let's see that potentially in action though. So for instance, this may be a little bit faint, but you can see in the image there is a series of points and colors. This is a point cloud of a piece of rock art. There's probably in excess of 10,000 points in there that are represented in this 2D image that you could rotate as a 3D space. Now that's not very useful for us as a 3D model, but what that is done is taken each photograph and found the common points within all of them. Then, if we were then to process that further, it would then turn into something that looks a little bit more like this, which is more recognizable to us as the object that we are trying to recreate using 3D photogrammetry. Let's take a look at a little bit more examples just now. What I'm going to do is exit my presentation and go over to another screen. So for instance, part of my work with Scotland's Rock Art Project is working through the raw data and the process data for 3D photogrammetry. So for instance, we have some pictures of a piece of rock art just here, and you can see that each picture is taken somewhat overlappingly, but there's about 13 in there. It's actually exactly 13. And this covers the entire scope of the rock art panel. I've then opened this up in Agisoft Metashape software just here. There are other softwares that are available that do this, but this is the one that we use, where I've uploaded the photos here. And what I can do then is generate a 3D model, which I can then view and adjust accordingly. As you can see, I can now view the 3D model at different angles. I can zoom in and see the textures for the model just there. What I might then do, because this is currently in a proprietary format, which is owned by Agisoft, I could export that as an object file, an OBJ file, which I could then open in something like Metashape, which allows us to more easily share these images, these models. So, what are some of the benefits of using 3D modeling? It is one of the easier entry points for 3D modeling. Photogrammetry has a lot of softwares that are available that does the actions of generating a 3D model. And really all that you need to provide is a computer and the photographs. You could even take the photographs on your phone, although potentially you'd want to get some higher quality photographs in order to get a higher quality image model. One of the other benefits is that 3D modeling allows you to visualize textures and details in a greater detail than digital photography. This is maybe a little bit difficult to conceptualize, but I'm going to show you some images that detail this in just a moment. You can also render the model in different ways, and that allows you to see the model in new and interesting ways that could reveal different parts of it. It's also an exciting new method of engagement. As with all digitization, we want to think about how users are engaging with the heritage that we're making available, and 3D photogrammetry is quite an exciting method of doing that. However, as with anything, what are some of the challenges presented by 3D photogrammetry? As with any digitization, there's the question of how you are preserving your digital data. As a digital archivist, this is something that I really do have to think about over the course of this project. Digital preservation for 3D models is time intensive. You'll want to be preserving not only your models, but the raw photographs, as well as associated metadata, which allows you to then reinterpret and understand your models down into the future. One of the other concerns is that you might need to check your specifications on your computers before engaging in 3D modeling. 3D modeling can be quite intensive and push the processing powers of your computer, so you may just want to test it beforehand. A kind of basic work laptop may actually not be enough to handle the requirements of these softwares. So it's worth investigating that before progressing. Finally, one of the other challenges is how are you then going to get people to access your 3D models? It's not necessarily the easiest thing to do. Photographs are a little bit more easy to share online. Websites such as Sketchfab, and I'm going to demonstrate that in just a moment, allows you to share your models online, but those come with their own challenges, things you might want to have to consider. Let's take a look then at 3D photogrammetry in Scotland's rock art project. Scotland's Rock Art Project is a 5-year AHRC-funded research project focusing on prehistoric rock art in Scotland. Its aim is to enhance the understanding and awareness of Scotland's prehistoric rock art through community co-production and research. in this project, we've trained community groups to record and construct 3D photogrammetry models of rock art panels throughout Scotland. We're currently working to preserve this data, over 900 captured panels, in a variety of digital archives. On the map just here, you can see the range of rock art panels that we've gathered throughout Scotland, red being the ones that we've recorded and validated, blue being the ones that we were previously suspected to exist in Scotland. This is an example of what 3D modeling can reveal in a rock art panel, and potentially something that can inspire some thoughts for yourself. This is an example of a panel from Castleton in Stirling. When looking at this panel in a normal photograph, you can see the faint outlines of cup and ring marks on the surface. Some of them are a little bit more difficult to see than others and require some maybe oblique lighting in order to see them properly. However, the 3D model, which you can see now viewed just to the right of this picture and above it, allows us to more clearly see these markings. And you can see that there's actually quite a variety of markings across the panel, revealing parts that we potentially hadn't noticed before. Additionally, the fine detail of photogrammetry and the way it can visualize textures in important ways reveals new parts of rock art to us. If you see in the bottom image, potentially what looks like a little bit of a static image is a particular render that we've applied to this model. And what you can see is that beneath one of the larger cup and ring marks, you can see there are markings underneath it. We previously thought that this didn't happen in prehistoric rock art, that rock art wasn't done on top of other rock art. But this has expanded our knowledge and understanding of what rock art is and what rock art does. So this is an example of how 3D modeling has revealed new parts of our heritage, and potentially how you could also apply it across your own collections. Here's another example of some more rock art just here, visualized in a 3D model. And here is another one just here. What I'm going to do is just exit just now and show you how we've been making this available publicly. We use the website Sketchfab to share these models. And you can see previously the one that I had demonstrated from the photographs is now available for public access online. We've used a little bit of different lighting here to emphasize some elements of the panel, and you can engage with it as a object for free. What you can also do is potentially apply this to something like a statue. Potentially you have a statue in your collection that you would want to capture in 3D modeling. This is one that we did over at Melrose Abbey. And it allows you to visualize the sculpture in a new way that is different to a photograph. There are some more examples on Sketchfab, and I would encourage you to seek those out in your own time. They're all free to access. There are some challenges, though, with using 3D photogrammetry that we found over the course of this project. As you can imagine, 900 panels, that's a lot of data, and there is a pretty significant amount of data management that has been required to ensure that it is usable and reusable over long-term preservation. This can add up for a long amount of time, so what I would emphasize is that if you're thinking about engaging in a long-term digitization project using 3D modeling, really consider your records management plan. How are you going to be preserving your raw data? How are you going to be making this available? What formats are you going to be using? Consider that from the beginning, and it saves you work later down the line. Finally, we've had to make sure our models have high quality metadata so that they can be reused. This is something that if you are looking to preserve 3D models as part of your collections, as part of your digital assets you'll want to be thinking about. We have really benefited from the work that's been done by the Archaeological Data Service, as they've developed best practice for 3D modeling. I would recommend taking a look at their website. I'll provide a link after this presentation that details and goes through what you might want to be thinking about in terms of the metadata, both for a project as well as for photogrammetry. Finally, public access has been a big point for us. We want to make our models publicly accessible, so we've used Sketchfab. However, as we start to consider the long-term preservation of our data, we need to move these models into our own digital repositories. Now, these digital repositories don't have an easy method for sharing 3D models online, so we've had to think about what is going to be available in the long term for these projects. So, in summary, 3D modeling. Think before you leap. 3D modeling, like any form of digitization, requires careful planning and preparation. You'll want to consider how you're approaching not only digitization, but also how you're approaching the metadata, your records management, and what you are actually going to be doing over the course of the project. Secondly, what is it that you are digitizing? Maybe you're thinking about objects in your collections that might be good for 3D digitization. I would really encourage you to think about what will you be getting from a 3D model that you would not be getting from, say, a digital photograph. Digital photographs and 3D models provide different information, but it is important to recognize that each has respective strengths when it comes to preserving physical formats. But also, finally, what I would say is that despite these challenges, be brave. 3D modeling has never been more accessible. It's never been easier. There are softwares in place that really take a lot of the work away from you and allow you to think about getting 3D models generated. Additionally, the latest iPhone has a LiDAR scanner built into it. So 3D modeling is only going to become more of a part of our everyday lives as we go into the future. So think about what 3D modeling can do for you and for your collections. I'm really excited now to potentially discuss this a little bit further with you if you have any particular ideas. But finally, I'll just put up that slide. If you have any questions that we don't touch on in this presentation, feel free to get in contact with me. But now I'm just going to close down the presentation and pass on back over.
Gosh, thank you, Freddie. That was incredibly exciting and very different from anything that I'm used to. And I've been working with archival material for a very long time now, but it really is exciting and brings it to life. We have the chat room's been really quite busy, and you can probably see that a little bit now. But I wanted to just touch on, because it has been mentioned about the LiDAR. They were saying, I don't know if it was Phoenix was first asking this question, about is it worldwide? Is it something that is available to everyone, or is it something, can it be used in Scotland basically?
As in LiDAR scanning?
Yeah.
Yes, so LiDAR scanning can be used wherever. Really, you can just buy equipment that you can use to conduct LiDAR scanning. And depending on the scale of object that you're working with, you would potentially approach different technologies. I will say that LiDAR scanning is not necessarily something that I focus on as a part of my my work. But if you have any specific questions about applying LiDAR scanning in a heritage context, I'd be happy to either pass your details on to some of our colleagues who use this as part of their everyday work.
Great. No, thanks, Freddie. Sort of talking about, carrying on with sort of software, there's someone, Ian has asked about open source solutions. And this maybe also follows on from a couple of questions in the Q&A. one from Una that says, what are the requirements for using the software? And another one around software is it free? Do you have to subscribe, or do you pay for it up front? Do you have any sort of advice on that?
Yes. So as with anything, the easier the software makes something for you, the more likely is there is a fee attached to it. What I will actually what I will show you just now is so for Agisoft Metashape, which is the one that we've been using, we have found that this has been quite an accessible program, which was very important to us because we were using a lot of community co-production. We needed to find a software that could be used by people who maybe had less digital skills but were engaged in archaeology as a project. One of the challenges that we found using this software is that the metadata that we've exported from it, we can only really export it as PDF, which, while useful, and it automatically generates this metadata for us, while useful, ideally we'd want to have metadata that could be reused more easily in something like a CSV file or a text document. So it's not, there are challenges there. What I will say is that there's a variety of softwares that can be used. MeshLab is the one that we use that's more open source, but there, as you may find with open source software, they may have a little bit more of a steep learning curve, but there is a community that is active and ready to support people in generating these models. So I would say do investigate. There are lots of different, you can even find applications on your phone that generate 3D models. Now, the quality may not be what you want, but there are lots of different options. So I would say investigate, make an assessment as to what you want as part of your digitization project, and then pursue that.
Yeah, no, that's good, Freddie. Someone actually on the chat room has mentioned that their trainee is using Meshroom, but beware, it is command line interface only.
Yes. So as with some of these modeling systems, there may be access issues. But again, investigate, take a look. Agisoft is the one that we used, but I believe you can find other systems that can be used. The name is completely evading me just now, but there are quite a lot of modeling systems that are available.
Great. Oh, thank you. It really is. There's a few things. I think Phoenix is coming in there saying reality capture. I don't know if that's an answer to what if that's the name you were looking for, Freddie, but there's quite a lot on the chat room if people do want to look at things. And we've also got a few links as well, which is fantastic. Just a really practical question. How expensive is it? David's asking. Yeah.
Again, unfortunately, that's really how long is the length of string. These systems may have these systems may have subscription models. They may have premium access models. So again, that is something that I can't answer as a baseline. What I will say is that if you're procuring a license for this equipment, it may be tied to the amount of computers that you use it. So you may want to consider, if you are using a digitization project, how many users are you going to need to access this software? And that may affect how expensive it is.
Okay. And on a very practical side, I mean, what Una is asking, what PC spec would you need for something like this?
In terms of PC spec, this is, again, so what I will say about PC spec is that what we found is that we've had to adjust the quality of the model that we're generating in order to more appropriately match the PC specifications that we're using. So we've been using HP Pro desktop computers, the specs are evading me off the top of my head just now, but I'd be happy to answer this after the presentation. And what we've done is we've found that adjusting the quality of the model at the end from, say, highest quality down to mid-level quality makes it more manageable to generate these models. Some of these softwares may allow you to do that, and that would be something that is worth investigating.
There's lots going on actually in this chat room, Freddie, but people are, I think, helping each other actually, which is wonderful. I'm just seeing if we've got any more questions here. Oh no, Una's saying thank you very much, Freddie, for answering that. There is another question that has come in, and it's just something that you spoke a little bit about it, but really what's the big difference between a 2D, like a photo, and a 3D modeling?
Yes, this is actually this is a really good question. So I'm going to demonstrate that just now. So with 3D modeling, something that we can do is, because, as I said, we've got the polygon mesh and then we've got textures on top of that, we can adjust the textures in exciting and different ways. So say, for instance, I'm going to actually open up Mesh Lab just now and open up a 3D model. And what this can allow you to do is visualize parts of the texture in ways that reveal parts of it that a 2D photograph just struggles to do. Even the best 2D photograph, you are going to be limited as to what you can visualize on it because you're only really viewing it from one angle. But say, for instance, we have this model just here. What I could do is apply this render here. And as you can see, the textures have just become a little bit sharper, which allows me to more clearly see what's actually happening on the surface of the panel just there. And this might be very useful. Say, for instance, you actually had an object in your collections that you knew had been handled in a particular way, or maybe something you really wanted to see what was happening on the surface of the object. This might be a useful way of revealing that information. Now, a 2D photograph is very good at capturing a high quality image of it, which you can view from one space. But this allows you to interact and engage with the object in a new way.
I'm just going to unmute there. Gosh, sorry, I'm trying to keep up here, Freddie. There was just one person, and I think I can answer this, Una, is it possible to get a copy of the chat? I will look into that. It's not been possible to date to do that, but maybe we can, because there's been a lot of links. I'll just try and work out something, and hopefully and include that. But I will be sending out lots of links, and Freddie has mentioned this before. He's got a PDF, we can attach that to the email with the recording and the feedback form. So you're going to have lots and lots of information from today and a copy of this recording. Just going on, because we're maybe one, maybe two questions, but here's one from Rebecca for you, Freddie. And is there a limit to how small you can 3D scan an object?
This is actually, okay, so this is a really good question. We engaged at Historic Environment Scotland, we engaged in a 3D modeling photogrammetry for our architectural models that are part of our collections. And what we found is that the very thin parts of the models, say, for instance, part of the hard card that has been used, part of them, elements that are quite small and fiddly, they struggled to be recreated using the 3D modeling software. Now, the more photographs you take for photogrammetry, the more detail you will get in your object. However, the more photographs you take and the more points you're generating as part of the model, the more intensive it is to generate the models. So you're balancing the quality of the model with the processing time that it takes. And for very small, very delicate objects, you may find that you need to take more objects and it takes more processing time in order to get them done. I would recommend investigating and just trying out different scales of objects. Larger objects, like, for instance, statues, panels, trophies. I'm trying to think of what you might have in your collections. These all might be able to be recreated in a more clear way, whereas very small and delicate objects may struggle a little bit.
That's great. I mean, I'm thinking a lot of people have got sporting materials, so that could be trophies, medals, so maybe something that is quite small actually. But definitely, you talked about the textures. I think that would be really impressive to get on these objects. So that's wonderful. I think really we need to close the day. We've run over time. I thought that was going to happen today. Absolutely. I'm just going to say if there's one question. Oh gosh, you can do using a digital microscope. That sounds quite exciting. I don't know if you've done that, Freddie. Have you used a digital?
We've not used digital microscope. We use DSLR cameras primarily for our photogrammetry.
Yeah. Any problems? Last question from Sandy Thomas. Is there any problems with having a shiny surface?
That's actually a really interesting question. I've not, just because of my work, I've not actually done any work on shiny surfaces. I don't think there would be. Again, this is one of the things that we've talked about. Photogrammetry is quite good at visualizing textures. So I don't think there would be. I think actually potentially would be quite good at visualizing a shiny surface, because you could see actually how smooth it was. Potentially there are some markings that you can't visualize with the naked eye, or are a little bit difficult to visualize. So it would potentially be quite good at visualizing something like that.
Great. I am going to stop. Lots of people saying thank you very much, Freddie, and I'm saying thank you very, very much for a incredible webinar. It's been really fascinating, and I know we are going to be sending out the recording and lots of links for people, and I hope that people have met up with each other on the chat room, and that's what it's all about, as well as networking with other people who've got similar interests. But yes, just once again, thank you, Freddie, and a round of applause from me.
Thank you, everyone, for coming along. It's been great to speak with everyone.
Yes, so I'm going to switch off and goodbye to everyone, and I hope you've all enjoyed it, and you'll be back next week for our next lunchtime webinar on digitisation and how to catalogue your objects. All right, see you all. Bye.